Hey everyone, my name is Neema and I take actuarial science. So I'm making this video to show you how to solve a question using Excel. So this question is from my module risk theory. We're gonna use recursive method to solve the question. So the question is, you're given a number of claims which follow a binomial distribution with m equals to 26 and q is a constant, given the exact value of q, and the claim sizes distribution are as follows. So you're given the x values here, and you're also given the probabilities. And also, you're given S. S is the aggregate loss random variable, which is subjected to 200 annual aggregate deductible. And you're told that the probability of aggregate payment more than 800 is 0.08540175. So your task is to compute the value of Q. First of all, our question is a binomial distribution, and we are given our M, which is 26, and we are now given the exact value of Q, and I have to find the value of Q. And also, our aggregate payment will be denoted by Y, and aggregate deductible by D, and our aggregate losses will be S. And also, what is important is that aggregate payment is always equal to the aggregate losses minus your aggregate deductible. And for how a deductible works, a deductible is when you get payment only when your losses are over or more than the deductible given. So your payment here, Y equals to S minus D plus. The plus means that you get your payment losses are greater than your deductible. So for this case, for any value of S that's greater than 200, and then we also have our claim sizes as denoted as X, and the probability of our claim sizes is PRX, and also probability of our aggregate losses will be denoted as PRS. And lastly, the probability of aggregate payments will always minus 200. The 200 is our deductible. And lastly, we have two key elements whereby since it's a binomial distribution, we know that we have to use our value of A, we also have to have value of B and Q to solve the equation. So the value of A will be given as negative Q out of 1 minus Q. Your Q is your probability of success, and B will be equal to in M plus 1 bracket Q divided by 1 minus Q. And your M is the total number of outcomes. And then you also have your probability of S equal to 0. This is the probability of your aggregate losses equal to 0 is equal to the PGF of the probability of X equal to 0. So this is a PGF of binomial distribution. So it will also equate to 1 plus Q bracket T minus 1 power M. Your T is the value of probability of X equals 0. And lastly is the equation, this equation here, which is Pn. This is the equation to find the probability of S equal to N. So it's going to be 1 over 1 plus A probability of X equal to 0, and summation of A plus Bj out of N times the probability when X equal to J and the probability of S equal to N minus. I just pasted the data here. So these are the values of X, and this is our values of the probabilities of X. And since we were only given your M, we were only given M, and then we're supposed to find Q, and we aren't also given A and B since A and B depends on the value of Q. So what I started with is I pasted this table, And I have to work, since we are also given the value, this value here, we are given the value of the payments greater than 800, which means the payments, the probability of S greater than 1,000, because your payments is y which equals to S minus 200. 200 is the deductible. So taking 200 on the other side of the equation makes 800 plus 200. So it's going to be S greater than 1,000. So since we are given this in the question, 0.084540175, we can find the probability of S lesser or equal to 1,000. So that to narrow this down, so we're going to take 1 minus this value here to get this. So from our equation, from our table here, we're going to just make, instead of creating a table of having a lot of values of S, we can just make a table to the value of 1,000, because we have the probability here of S being lesser or equal to 1,000. So we're going to just have to sum up this to get this in order to find our value of Q. So this is how it's going to, and then I needed to create a new table just to make things easier and so that I can solve for it. So I created a table with this column, the S column, the payment aggregate losses here to 1,000, because that's the only payment losses I'm going to use. And then there is this column here. This column is the first part of my equation. This part of my equation, this part, the 1 out of 1 plus A probability of X equal to 0. Yeah, I created this table here, and then which is, so this is 1 divided by 1 out of D5 is this value here. D5 is my A, and G3 is my probability of 0. So that's the formula for that first cell. And then I just dragged it down to get this formula, to get this result. So column was my probability of S equal to S, the probability of aggregate losses. So here, for the first value is the probability of S equal to 0. Here, the probability of S equal to 0, you can find it by using this formula, which is 1 plus Q bracket T minus 1 power M. And I said T is the probability of X equal to 0. Going back here, the probability of S equals 0 will be 1 plus D4. D4 is Q times G3. G3 is my probability of X equals 0 minus 1 power D3, which is my M. So that's the formula for this first cell. Okay, then the next one is this. We start to calculate the probability of S equals to N. So for the second formula here, but remember we have already done this first part. So the next thing, we're gonna just insert this times this whole thing. So we're gonna just insert the formula from this formula here. Okay, so see, so the first J4 is this, that's the first part of our equation, times D5. D5 is A plus D6, which is B, times I, which is your S, divide by the value of S again, since S is the same value as your X here, times your G4. Your G4 is this. Your G4 is the probability of X equals to 50, which is the same as the probability. G4 is your probability X equals to 50. And then lastly, you have to multiply with your probability of S equal to 0, which is K3. So that's how I got my second value. And then for my third whereby its probability of S equal to 100. I'll repeat the same thing I did here. So I'll take my J5, which is this value here, times my D5, which is my A, plus this bracket, inside bracket, plus my B, which is this one, times I4. I4 is the value of S50, and then divide by I5, which is S100, times G4, which is my probability of X equals to 50, times my K4, which is probability of S equal to 50, plus D5, which is again my A, plus my B, times I5, which is S equals to 100, this value here, divide by 100 again, times my G5. My G5 is the probabilities that X equal to 100, times my K3. My K3 is probability of S equal to 0. So after that, I'm going to get that value. So I'm going to do the same for all these values here to get the value of S. And then for the value of Y, Y is the deductible, which you just get paid. Yeah. Y is the payment that is just made whenever your S values or your loss values are more than the deductible. So here for these values here, for the value of 0, 50, 100, and 150, your Y values is gonna be 0 because S is lesser than 200 in this part. That's why it's 0. And then from your value here, 200, you're not gonna be paid anything, but so your value is gonna be 0 to 0 again. And then from 250 to 1,000, you're gonna get payments because it's greater than your deductible. Then after that, the probability of Y is the same as the probability of S here. So for this question, we weren't given the value of Q. We delete this to 0. So yeah, this is how it was before I solved for the value of Q. So to solve for Q, I'm gonna have to use this Excel function called data solver. So for the first thing, you're gonna have to set your objective. My objective is that I want this value here. I want this value here. I want this value M24 here to be equal to this value, because this value is 1 minus the probability of S greater than 1,000, and M24 is the probability that S is lesser or equal to 1,000. So I want this value to equate to 0.9145985. So yeah, I want this value here to equate to that. And then by changing the variable cell, my Q is the variable cell, so D4 here. And then I can add some constraints. So I added one that I want to make M24, which is the summation of probabilities from S equals 0 to S equals to 1,000 to be this. After that, I just can solve, and then I'll get my value of Q here. So I got my value as 0.105779403. So after getting that, you also got my value here as I wanted. My value here as I wanted. This value is the summation of the probabilities of Y here, which is also the probability. Probability of Y is the same as saying probability of S minus 200. So the summation of 0 to 1,000 here is the probability of S of 1,000 will be equal to 0.91459856164. So from that, we've solved for Q, which is also solved for A and B. This is because the formula used in A relates to Q. So you see A is equal to negative D, which is negative Q, out of 1 minus D, which is Q. And also B is the same. So B is M plus 1 multiplied by D4 divided by 1 minus D4. So that's it for my video, and I hope you've understood and got the main points on how to solve this. And thank you a lot for listening.